Good morning, everyone. I, on behalf of Institution's Innovation Council, Tripura University, would like to welcome you all to the workshop on instrumentation for natural product characterization having medicinal properties. Today, we have with us Mr. Rajat Ghosh, Assistant Professor from Department of Pharmacy, Tripura University. I welcome you, sir, to this workshop. Over to you.
Unless screen is visible. मंदाकिनी क्या
No, sir, your slide is not visible yet.
can you hear me?
There is a connectivity issue, so we are waiting for speaker to join again.
स्क्रीन दिखाई दे रहा है वॉइस आ रहा है आप स्कैन कीजिए सर शेयर स्क्रीन क्या क्या हाँ Instrumentation for product medicinal innovation council of the universe. Myself Rajat Ghosh, president of pharmacy. So in this department we are working on lots of medicinal plants and trying to find the bioactive molecules. So before going to tell about this instrumentation which we are using for this purpose, I would like to tell you people the brief idea on how we are going to collect the extract materials or the plant materials through the extraction, and afterwards we are trying to do the characterization with the help of analytical tools. in this slide, I have tried to show you people that the extraction of oxalate, but there are a lot of different methods are use the solvents and at the temperature or at the boiling point of particular solvent, they are doing the extraction. So what is happening here? We one inside the solvent extraction, we have which one to be the polar and non-polar. So depending upon uh, choice, find it out the what type of solvent we can utilize for this extraction. One extraction has been over, then for the distillation of that particular. So what will happen whenever we use the nitrogen is boiling point will come. So at the low temperature we are able to distill after when isolate or we can so TLC is one of them method which one is going to find out or help us how many components are present in the extract. That are all pre-coated on the aluminum sheet and they have the fluorescent indicator. So what is happening? The way I am showing here, because disturbances whenever we are doing these are chemicals we have isolated chemicals. This chemical total then we on the state and afterwards we are keeping it inside the mobile phase or in the developing. So allowing this keeping in 20% of the TLC plate. So one chamber. So under UV chamber, we can easily detect the spots which in the naked eyes we can't find out. So this is the visualize the spots under the UV chamber, and these are the spots of the same components or the mixture of the components are present in one extract. So what is happening here? We can find it on the left hand side. This is the highly concentrated one. So whenever there is a concentrated solution we are taking for the TLC, there is a separation will not be taken place properly. So we have to do the dilution. At the same time, we have to keep in our mind the mobile phase should be chosen in that way, but the proper separation will be taken. So in so many cases, we are doing it with the mixture of polar and non-polar solvents. So here in this slide also, I'm trying to show you people that in the left hand side, these are the two spots which we have been able to find out in the right hand side, but in the left hand side, those two spots are coming all together. So it's not we are not able to find it how many spots are there. So this is a too concentrated one. So we have to do the dilution of our target components or extract, and then we have to do the or develop the TLC. And these are the solvents which one we are choosing here. So what is happening here, it has been written properly in this slide that increasing polarity is going to elution power will be more. So we are mostly using in the as a mobile phase in the thin layer chromatography the mixture of polar and non-polar solvents. So it has been found that the spots those are coming close to the bottom part is highly polar, and those are coming going up, these are all the non-polar components. So by with the help of this knowledge of TLC, we are utilizing this one for the column chromatography. Now in the TLC, this is the actually RF value we are calculating with the help of that solvent and how much solvent has been traveled and the solute has been traveled. So that ratio we are going to find it out, and that is coming in form RF value. Why I am telling this RF value? Because that concept will be utilized for the high performance thin layer chromatography. So this is the HPTLC. Now what in we have our component, but in HPTLC instead of spot we are using band of our components. So this is a sophisticated instrument, and is the cost is coming almost 50 lakhs for this particular company which one they are, we are showing here. But I'm not going to promote any company here, though is a what to say, it's a renowned company which one is using or developing this high performance thin chromatograph, and people are using this one. So this is the HPTLC results, where on the top A, B, C, these are all the bands are showing, and in the part this chromatograph is coming. So these chromatographs are coming from RF. Now you can check in x-axis, it has been written 0 0.0, 0 0.1, 0 0.2. So all these are the RF values, and this highlighted one or marked one is the actually area under curve. So it's showing how much component you have in that particular mixture. Suppose you have only one component which one you are targeting, that time it will show only the single peak, and this chromatogram is going to help us to generate our idea on how many components are present in a mixture. Then we are going for the column chromatography. Now why this required? Suppose you have mixture of components in your extract, so that time we need to utilize the column chromatography method for separation. Now it's a simple one. We need one column, we need solvent, we need the mixture of components which one we are targeting to do the isolation of all the molecules, then adsorbent or stationary phase which one you can use the silica, glass wool. So this is the whole column pattern. Now in this slide you can find it out. See in the left hand side, this is the sample one which has been loaded along with this stationary phase. The bottom part is stationary phase which one we have taken here, and then the sample, and then we are allowing our mobile phase to run through this one. So in the red and blue mark, they are showing these two different molecules, or is the mixture of molecule where this red and blue is present. Different types of molecule is present. Now, depending upon the polarity of the component, with the choice of our solvent, what type of solvent we are going to use. If the component is polar and we are choosing the component is solvent is polar, that time our component will be solubilized into polar solvent. If our component is non-polar, it will be solubilized in non-polar solvent. So what is happening actually in the TLC, the spot which one is getting at the bottom, close to the bottom part, is actually polar, and the TLC spot which one is showing on the top is the non-polar one. So it means through column, the first spot which one will be collected will be non-polar component. The top spot which has been found, which has been established in the TLC, through TLC, it will come out from the column first. So initially we are going for utilizing the non-polar solvent, and afterwards we are going to increase the polarity of the solvent system or mobile phase. Then we are allowing go through the column, and we are going to try to separate out all the molecules which will be present in the mixture. Then this is the high performance liquid chromatography. This HPLC method, actually we are utilizing to find it out the purity of the component. Suppose you have the single component which one you have gone to isolate from the column, and then you are injecting to the HPLC, you will ever find it out how much purity of your component which one you are targeting is present. Suppose it is unknown component. So HPLC is going to help you to find it out with the help of its chromatogram, and this is the GC we are using when we have the thermostable components, and mostly for volatile components we are using this GC because it should be converted into the gaseous phase, or that's why the components those are volatile or thermostable, we are generally utilizing this GC. Then IR mostly we are doing these instruments we have in the Department of Pharmacy, and mostly we are using to find it out the functional groups. Suppose carboxy groups, hydroxy group, amine groups, their presence we can easily detect with the help of IR. In so many times it has been found that suppose the herbal formulations we are doing, and that time we are trying to find it out the formulation, whether our main molecule which one we are targeting, it should be present there, whether it has been present in an intact way or it has been degraded. So by IR also we can find it out whether that functional group is present or not, which one we are targeting to be present, or it will be responsible for the activity. And this is the IR spectroscopy, which one is showing that is the range which one the x-axis of 500 to 1500. This is the range is the fingerprint region, and 1500 to 4000. This is the functional group region. This is mass spectroscopy. So this instrument is actually we are using for the finding out the molecular weight of the components, and nowadays people are using tandem mass, means MSMS we are using with the fragmentation patterns of components. Now this is the spectral data of mass, where with the help of this spectral data we are able to find it out molecular weight of particular component. This is the though it is in our university, and we don't have personally don't have in our school have them, and this is the sample sample which we are trying to take the NMR, get the NMR of this particular sample, and it's actually pure. And this is the NMR. So is showing for the illustration I try to given to people. So here we get out the blue one is CH3, red CH2, and green one is the CH part. So three different types of protons are there. So that can be proton. Same time we can go for the carbon also, which is also going to find different types of carbons are present. So this is the one example of the I have shown here. Now I would like to show you people few videos. This is the first video which one has been done with the uh, extraction has been done with the help of Soxlet. Now this is what is happening here. This is a Soxhlet apparatus where the sample has been taken, and this is the setup of the Soxhlet apparatus. For the Soxhlet extraction, now sample has been loaded in the Soxhlet apparatus. At the same time, solvent has been taken, and now it has been capped. Now heating has been provided. So once it has reached to its boiling point, the solvent which one we have taken, now whenever it will reach to its boiling point, that solvent after condensation it will come down to the chamber where we have taken our component or the plant material. Then afterwards the extraction has been started. So this process will be continued until or unless we'll find it out the colorless solvent is coming out. This solvent is not having any color. So that is the process of the Soxhlet extraction until or unless we are going to extract all the components from this plant material, dried plant material, which is in form of powder, has been loaded in the Soxhlet apparatus, and then we are going to do the extraction. Then once it has been over, then we are going to do the evaporation of the solvent or distillation of the solvent. So this is the rotary evaporator where the chiller is there to do the proper condensation of the solvent. Then the vacuum pump is there, which one is going to decrease the boiling point of the particular solvent, and then we are going to distill of the our extracted material, distill of the solvent from the extracted material or extraction, which one we have collected through the Soxhlet extraction. So this one will be with the help of rota, we are going to do the distillation of this particular solvent. So its boiling point, suppose if we have taken a solvent which boiling point is close to 80, so with the help of vacuum we can decrease the boiling point. So at the temperature of 50 or 60 we can do the distillation of this particular solvent. So that time the component, if it is thermolabile at high temperature, so its degradation will not be taken place. So that's why we are using the vacuum. In so many cases, which one I have told you, people are using liquid nitrogen also to low down the boiling point of a particular solvent. So instead of vacuum, they are using the liquid nitrogen. Then this is the TLC. So this is the sample which one has been collected. Suppose after purification in a pure form, the sample has been collected, and then we are going to dissolve it in a solvent in which it will be solubilized, and then we are going to develop the TLC chamber or TLC plate. In the TLC chamber, where we have to keep our mobile phase, which one we are utilizing for this particular purpose, the mixture of polar and non-polar, the mobile phase, and then we are developing our TLC plate and keeping it inside the TLC chamber. So it has been solubilized in that particular solvent. Here we have shown that in chloroform it has been solubilized. Now in a developing chamber, we are going to take our solvent mobile phase, and mostly we are using the mobile phase, the mixture of polar and non-polar, so that you have as a mobile phase, chloroform we have taken, and we will the non, because chloroform is polar, so along with this we are going to choose one non-polar solvent. And then the TLC has been kept inside the chamber, but the spotting has been done with the help of capillary. So then the mobile phase will be allowed to move to this TLC plate. And almost 80% of the TLC plate, it will cover the solvent travel will cover up to 80% of the TLC plate, and then we'll keep it off. And afterwards, when the TLC plate development has been over, then after drying, we are keeping it inside the TLC chamber or UV chamber. So under UV, so next one is HPLC. Once it has been developed, we are trying to so this is the HPLC where the sample is being will be injected inside the instrument. This is all the top bottoms they are having the mobile phase. All the solvents we are using, which are we are using for the mobile phase as a mobile phase. So we are keeping in the jars, which are we are watching here, and this is the monitor where we will find it out the formation of chromatogram. After injecting the sample inside the HPLC, now here in this system we are doing a reverse phase method we are applying here. So in a normally chromatography is normal phase and reverse phase, two different types of HPLC we can use. So here the reverse phase means column will be non-polar and our mobile phase is the polar. So we are as a mobile phase we are choosing water, HPLC grade water, and acetonitrate HPLC grade acetonitrate. So the mixture has been taken, and this is the chromatogram which has been developed. Now one interesting thing I would like to show you people here, the purity of the component will be easily we can trust out from this chromatogram. When the result will be given, I will show you the purity. See, this is the area which one is showing 100%. So it means it is 100% pure. The area percent is 100 means component is 100% pure. It is only. So whenever we have been able to isolate our component through column or through HPLC with the help of analytical HPLC, that time also if we inject afterwards and the component is pure, it will show like this. If there is a mixture of components, that time that area percent will not show you that 100%. So 100% means only single component is there. And this is the instrument, IR instrument, which one we have in our department. Actually, this is it. So here we are going to take our sample, keeping it. The help of IR, we are going to find out the functional groups. Any functional groups are there, we are going to help of IR. So we are going to methods are going to collect chromatography in the mass, NMR, and IR. We are going to collect this spectral data. This is a component is it has been shown here. So what's happening here is the range from channeling range 400,000. The 1500 is the fingerprint or so what is this particular one is close to 1800. So uh, so this particular
I apologize for the connection. There is a technical issue. We are waiting for the speaker to resign.
Can you hear me, Mandagini?
Yes, sir.
Okay, just a minute. The screen is visible, no? Screen is visible.
Yes, sir.
Okay. So actually, what is happening here? We are whenever we are doing the extraction. Suppose we have chosen any polar solvent. Suppose we are going to take methanol or ethanol, and then we are doing the extraction. So after collecting the extract, we are going for, first of all, we are going to distill off the whole solvent. So once the solvent has been distilled off, then we are going to find it out that whatever chemicals could be present here. So for this purpose, we are doing chemical test, and those chemical tests may be for the presence of alkaloid, maybe presence of for flavonoid, for saponin, tannin. So afterwards, whenever we are distilling of the particular solvent which one we have taken for this fast extraction, then we are going to take that residue after evaporation of the solvent for the fractionation. Suppose the fractionation purpose, we have taken a solvent which one is highly polar. So we are trying to take such kind of solvents, those are not miscible. So through the separating funnel also, we can easily isolate those components, and two layers, which one the components could be going for the solubilization depending upon their polarity. So afterwards, suppose we have chosen such kind of solvents where through separating funnel also we can separate out, and we have chosen that 3 different or 4 different type of fractions. From those fractions also, after distilling of our solvents which one we have taken for the fractionation, we are going to do the chemical test. Suppose for the first one, in the methanol extract which one we have taken, and then we have for the methanol extract residue we have taken fractionation, and that methanol extract has shown the presence of alkaloid, flavonoid and saponin. But in fractionation, it has been found that the first 2 fraction is not showing the presence of alkaloid. Suppose third one is showing the presence of alkaloid. So we can find it out the alkaloid which one initially we have been able to trace out in a methanol extract or in the initial part of the extraction. Then in fractionation, the first 2 fractions is not showing the presence of this alkaloid. So that alkaloid is present, or that it has been traced out in the third one. So that third one will be afterwards we are trying to find it out how many components could be present here. So with the help of TLC, we can find it out how many components are present. Afterwards, that TLC concept we can bring for the HPTLC also. So that HPTLC, once we have been able to establish the how many possible spots or possible components could be present in the third fraction, where we have been able to find it out that initial phase or the initial extract where alkaloid was present, and that alkaloid has come to the third fraction, then we can do the separation. Now for this purpose, we can use the column purification. So that column purification, where we are trying to find it out all these components depending upon their polarity. Suppose in the one small example I would like to show you people here. Suppose this is the TLC. This is the TLC. Now, what is happening here? The spot, this spot, this spot is highly non-polar, a little bit non-polar compared to this one. So the spot which one is close to this bottom part is polar, and this one is non-polar. So that concept we are taking for the column purification. So whenever we are using the column purification, we are keeping in our mind this component is non-polar and this component is polar. So what will be happen in column? The way we are finding out in the TLC, if this non-polar part compared to this spot or component which one is polar, it will come out fast from the column. So we are choosing such kind of solvent which one is non-polar. Or afterwards, if non-polar solvents we have continuously we are allowing non-polar solvent to flow through the column, and we are not able to find it out. We are not able to find it out the component. Then we are going to increase the polarity. Now, how to increase the polarity? If initially, suppose we have taken the polarity, it has been increased 5% or 10% or 15% at a time. So what will happen? It may be possible that these two spots together is coming. So gradually we have to increase the polarity of the mobile phase, which one we are using for the column separation or column purification. So initially we have to do that this spot, particular spot will be isolated with the help of column. And then once we have been able to isolate this component or this product, then we go to increase the polarity. And that polarity will be increased, suppose 0.5%, 1%, 1.5%, like that way. So if the polarity has been increased, so this component will be afterwards will be isolated. And next target will be the last one. Suppose you have three components here, three spot. So first of all, this one has been able, we have been able to isolate this one, or remove this one from this mixture. Then we have been able to remove this one from the mixture. So remaining is only one. That time, at the same time, you can increase the 100% polar solvent you can take, and you can allow to run through this column. Because whenever you have the single spot, that spot will come out with the 100% polar component or polar solvent. Okay, so this TLC concept will be utilized for the column separations. Now, this TLC concept, whenever it has been used for the column, now the column, whenever we have been able to isolate the component, still, if suppose our UV detection will not be that much able to find it out if there is 2-3 spots are present or not, we are going to find it out with the help of HPLC. Suppose we have injected the sample, we have injected in the HPLC, and you are going to find it out, and the area is showing is 100%. That time you can say, yeah, I have only one component. Though for the isomers, the concept is different, but we are not talking about the isomers. If isomers are present, that time still it may be possible the mixture of component could be present, and that could show also the the highly pure component. But if there is no presence of any isomer, that time also you can say if 100% pure, it is single component, it is pure. If there is a mixture of components, suppose you have injected these three together, so in HPLC, what will happen if this the mixture has been injected in HPLC? It may be possible you may get it is 50%, 40%, or then 10%, like this. So you can find it out how many components could be present there. So HPLC is going to help us whether our component is pure form or not. And then once you have been able to isolate all these components in a pure form, suppose you are able to take all these components, those are depending upon the different polarity, then you can go for the NMR, mass, and IR. So these all NMR, IR, mass is going to help you for the characterization of a particular component. Here, what is happening through the proton NMR, we are able to find it out how many different types of protons are present. Suppose if I go to show you people this spectral data, so if you can find it out in this particular spectral data. The CH3 is one type of proton. So this whole 3 proton is coming all together here. Now, don't think for all these things. This is the splitting pattern has been shown for their neighboring protons. So we are not going to explain all these things here, because that time it will not be that much helpful for you people, because it is 3 different types of proton we have to keep in our mind. So due to 3 different types of protons, we are getting 3 different peaks. And the peaks, we are always telling it the components are the protons which are shielded one, it will come close to 0. And this deshielded one, due to the presence of this oxygen, it has been deshielded, so it has been here. And this due to this oxygen, it has been deshielded, so it has been here. So this is the position of the protons. So there is so many ranges are there for different types of protons. From those ranges, we can find it out. Whether the components which one we are getting or which one we are trying to find it out, unknown one, how many different types of proton to be possible, present, and possibility of the structure, we can draw it. And at the same time, the carbon-13 also is going to tell you how many different types of carbons are there. Now, the people are also trying to find out if you have got any type of component in form of crystal. That time, X-ray crystallography is also help you to say the orientation of your atoms in the particular molecule. So these all the analytical tools we can utilize for the characterization of our natural product, and that afterwards, once we have been able to isolate our that particular component or one single component, we have been able to purify with the help of chromatography methods. That time we can characterize these molecules with the help of the spectral data. So utilization of IR, utilization of NMR, mass, and X-ray, these all are together we are utilizing. So the utilization of HPLC, utilization of column, utilization of TLC, all this playing a vital role for the characterization of any particular molecule which one is present in a medicinal plant. And if we are trying to do all those type of experimental work, at the same time we have to find it out if any particular extract is showing bioactivity. Suppose I have told you people the first one we have taken the methanol extract. Then methanol extract, it has been, suppose it has showing the promising antimicrobial activity, and then we have gone for the fractionation. Suppose 3-4 fractions we have collected from this one, and it has been found that the fraction number 4 is showing promising antibacterial activity, others are not showing. So it means the initially in the methanol extract, which one we have collected, which one is showing the promising antibacterial activity, that molecule has been fractionated or has been removed or collected through that fourth fraction in form of fourth fraction. So that fraction, if it is a mixture of component, then we are going to find it out one by one. We have to purify this one with the help of column. Also, we can do the purification. And for purification, crystallization is another method. But if it's a mixture of component, it's tough to do the crystallization for the purification. But it is possible for the synthetic chemistry people using crystallization for purification. But for the natural chemistry people, with the column flash chromatography, we can utilize for all those type of purification methods. And once we have been able to isolate one by one all the molecules, and then you can go for check out whether which particular component has shown promising antibacterial activity, and that particular molecule you can target and can characterize with the help of analytical tools. So that's all. If still in our future we are trying to find it out, because today I could not show you people the whole laboratory setup. Here are only few videos I have been able to show you people, but once we will do it in our laboratory, we are trying to do it in our own hand or ourselves. That time we will come to know how we have to do all this to experimental works. So thank you so much. Hope in near future again we will try to find it out, all those type of characterization of particular natural product, and we'll try to learn few more from this. Thank you.
Thank you, sir. Thank you for your presentation. Thank you for giving us your valuable time. No questions are there in the chat box till now. So we are closing this session here.
Yeah, if anyone is having any inquiry, they can do it.
Thank you, sir.
Welcome.